Today, our learning target is I can convert between mixed numbers and improper fractions. So we talked a little bit about this in our last lesson, and we're going to continue on it today. So our dot talk to start out with, go ahead and say how many dots, how many full dots do you see, and how do you know how many? Okay. So for our math warm-up today, we're going to do another choral counting. Remember, it's just like counting whole numbers, except we're talking about counting unit fraction, the same unit fraction over and over. When I look at this example, I see I have 3 pieces in each whole, so I know the unit fraction I'm working with is 1/3. So let's go ahead and count together. 1 1/3, 2 1/3, 3 1/3, 4 1/3, 5 1/3, 6 1/3, 7 1/3, 8 1/3, 9 1/3, 10 1/3, 11 1/3, 12 1/3. What do you notice as we look at this page? What do you notice about another name for 3/3, 6/3, 9/3, and 12/3? Hopefully, based on after what we talked about last week too, every time that we have a whole, we're filling up 3/3. So 3/3 is going to be the same as 1 whole. I see up here 6/3, when I have 6 1/3 filled, that's going to give me 2 wholes. When I have 9 1/3, remember 9 divided by 3 gives me 3, because remember this is also a division sign, or 12 divided by 3 is going to give me 4, or I could think of it as 12 1/3 is the same as 4 whole. Okay, so we've talked about different ways we can represent fractional values. One way that we've been using a lot is a fraction strip or a fraction bar. Also a number line. Remember, the key on our number line is we're counting the jumps. 1, 2, 3, 4 jumps. So we know our denominator is going to be 4 in here. And then we'd be at 3/4 at this one. We also can think of a fraction as part of a set of objects, or we could think of it as a circular area model. Again, thinking about the clock in 12 hours to help us break it down evenly. So remember, we've talked about having different nicknames. All of us might have a nickname that someone in our family calls us, or maybe on a sports team. Even though we have a nickname, we're really the same person, and we use specific nicknames for different reasons, just like we use different equivalent fractions and decimals for different situations. The whole idea is that we want to be able to go back and forth between them so that we can figure out the one that's going to make the problem easiest to solve or visualize. Okay, so today we're going to talk about proper fractions. Remember, that was a fraction with a numerator that is smaller than the denominator. Okay, so if our fraction is proper, the numerator, or the number on top, is going to be smaller than the denominator. We do not have 1 whole. It's got to be, this is a fraction. A proper fraction is less than a whole. So all these would be examples of proper fractions. Remember, the numerator is smaller than the denominator, so we have less than 1 whole. Those would all be proper fractions. We also have improper fractions. That is a fraction with a numerator that is equal to or greater than the denominator. So improper fractions are going to be either equivalent to 1 whole, like this, or would be greater than a whole, where the numerator is greater than the denominator, greater than 1 whole. Okay, think of it because the 5 is larger than the 2, meaning I have more than 1. If I have 2 pieces make me whole and I have 5, it's going to be really hard to carry them. So I think that being improper, that it might be hard to carry it, I might fall down. Okay, a mixed number is a fraction with a whole number and a fraction. So it's mixed. It's got a whole number and a fraction with it that are combined together. So if I look at 2 1/2, I can see I have 2 wholes and 1/2. When I look at them together, I have 2 1/2. So today we're going to talk about how we convert one to the other. So convert, remember, means to change a value from one form to another. But remember, we're just changing the form, but the value stays the same. We're not changing how much it's worth. Same value, just the form. Am I going to write it as a fraction, a decimal, an improper fraction, a mixed number? Okay, so I could have 4/4. I could convert it to $1. It's still worth 100 cents and it still has the same value. I could think of 5 halves. It's still equivalent to 2.5. It's just another form or another nickname or another way to write it, but I'm not changing the value at all. Okay, so on your number line, on your whiteboard or on your paper if you're at home, go ahead and draw these 3 columns: improper fraction, mixed number, and decimal. And we're going to do a review from yesterday. What would the improper fraction for the picture be? What would the mixed number be? And what would the decimal equivalent be? Go ahead and write them down. So first I'm going to do my improper fraction. Whenever I'm doing a fraction, my first job is to count up how many pieces make a whole. In this picture, 3 make a whole. I have 3 thirds here, and I also have 2 more thirds here. So if I put them together, I would get 3 thirds, 4 thirds, 5 thirds. So my improper fraction would be 5 thirds. My mixed number would be, well, how many wholes can I get out of that? I see in my picture I have 1 whole, and then I have 2 thirds that remaining, so that would be my mixed number, 1 whole and 2 thirds, or 1 and 2 thirds. In my decimal form, I'm going to look at my mixed number. I still have a whole. That's not going to change. That is in my ones place. Then I need my decimal, 2 thirds. I know that each part of a third is, remember, 0.33 repeating. So if I have 2 of them, I'm going to have 0.66 repeating. So those would be my answers for this. If you're at home, you're going to watch the video separately instead of having it embedded in this video because it just gets too big. That's connected to your assignment. In class, your teacher will display the video for you. So now we're going to convert the improper fraction, remember improper because the numerator is bigger than the denominator, into a mixed number. So I want to have a mix. I want to have a whole number and a fractional piece. First, I need to visualize it. So if I think about 5 halves, my first question I'm going to ask myself is how many pieces make a whole? In this, I see that 2 is my denominator. So 2 means I need 2 pieces to make a whole. So I'm going to think about, I'm going to decompose into how many wholes as I can. So right now, if I take 2 away, I'd have 2 halves. That would be a whole. So now I'm going to have 3 halves left. That's still enough to make another whole. So I'm going to take another 1 whole and take out another 2 halves. So now I have 2 halves plus 2 halves. I'm at 4 halves. And I still have 1 half left. So now I'm going to combine my 2 1 wholes and my half. And my answer is going to be 2 whole and 1 half. That is how I would figure out my mixed number from this improper fraction. Okay, so let's do another one. 6 thirds. My first step, how many pieces make a whole? Well, in this one, my denominator tells me I need 3 to make a whole. So I'm going to take out 1 whole first. That would be 3 thirds. Now I still have 3 thirds. If I take 6 thirds minus 3 thirds, I'm still going to have 3 thirds left. 3 thirds is another whole. So now I'm at 6 thirds. I've used all of them. So if I wrote this as a mixed number, it would just be 2 whole. I don't have any extra improper fractions left. I've used them all up. Makes sense because look at 6 divided by 3. I know that the division sign is the same as my fraction. 6 divided by 3 is going to give me 2. So my numbers match. Okay, so now I'm going to think of 11 fourths. So picture that in your head. Picture 11 fourths. I want you to make an estimate. How many wholes do you think it's going to be? And then let's check with our answer. So let's try it. First, I'm going to take out 1 whole. So I'm going to say 11 fourths. I can decompose it. If I take out 4 fourths, I have a whole gone. So 11 minus 4. I'm at 7 fourths. I have enough. I can take another whole out. Another 4 fourths. So now I'm at 4 8. I have enough to take more out. Decompose it. And now I don't have enough for another whole. So I'm going to put my whole back because I would need 4, 8, 12. I don't have quite enough. I'm at 8, 9, 10, 11. I have 3 fourths left. So I have 2 whole and 3 fourths. So to rewrite it, I would write it as 2 whole, nice and big, and then the 3 fourths next to it. Okay, our next one, 31 tenths. So I want you to picture this one in your head. How many pieces make a whole? How many am I going to have to pull out every time to make a whole? Well, let's start taking some out. I'm going to take out 10 tenths to make one whole. If I have 31 minus 10, I'm at 21. I have enough to take out another tenth. So I'm going to take out another 10 tenths. So now I'm at 20 tenths. I have enough that I can take out another whole. I'm going to take out another 10 tenths. Now I'm at 30 tenths, and I have 1/10 less. So I've got left. So I've got 1, 2, 3 wholes and 1/10. So my answer would be 3 and 1/10. Okay, now we're going to go the other way. Now we're going to start out as a mixed number, and I'm going to change it into an improper fraction. I'm still going to visualize because every time I'm working with fractions and decimals, I'm making a visual in my head. So I'm going to picture 1 whole and 3/4. My first thing I ask myself is still, how many pieces make a whole? Well, I still know every time I get to 4 pieces, I'm going to be at a whole. So I'm going to decompose my 1. So I'm going to take the 1 and decompose it into 4/4. Remember how we said we can write one whole any way we want? We could write it as 4/4, 10 tenths. But in this example, 4/4 is going to be the best way to write it because now I can easily add it to the 3/4 that I have left over. So the 4/4 plus the 3/4 is going to give me 7/4, which would be my improper fraction. Okay, let's try it. Okay, so I want you to picture 3 and 1/2 in your head. So maybe you're picturing circles, maybe you're picturing $3.50. How many pieces do I need to make a whole? So if I look up here, I look at my denominator, I'm going to need 2 pieces to make my whole. So I'm going to pull over. If I take a whole out, that's going to be 2 halves. So now I've taken out one of my wholes, so I'm down to 2. I need to take out another 1 whole. Okay, so now I have to take out another 2 halves. So now I'm down to 1 and 1/2. I need another whole. I can decompose it to another whole number, which would be another 2 halves. And now all I have left is my 1/2. So I'm going to count 2 halves, 4 halves, 6 halves. One more would be 7 halves. 7 halves is the same as 3 and 1/2. Okay, I want you to try this one on your own. To start, we'll work up pieces at a time. So it's your first job. I have to identify how many pieces in here are going to make a whole. So how many pieces do I want to make or use to make a whole? Well, in this example, we're talking about thirds, 2 and 2/3. Every time I come up with 3/3, I'm going to have a whole. So now I want to decompose. So I'm going to take my 2 and I'm going to break it into a 1 and a 1 because I know that 1 and 1 makes 2. So now I've got 2 1s. Now I'm going to write down, well, I want them in thirds. That's the nickname I want today, is thirds, because it's way easier to add them together. That'll make it easier for this problem. So I've got 3/3 is 1 whole, another 3/3 is 2 wholes, so now I've taken care of that, plus these extra 2/3 from my mixed number. Now I'm going to add them all together. 3/3, 6/3, 7, 8/3. So 8/3 would be the way I would write 2 and 2/3 as an improper fraction. I could also count 3, 6, that's going to give me my 2 whole, and then I have those 2/3 extras. Okay, I want you to try this one on your own, and then we'll check it together. How would you change the mixed number 1 and 7/10 into an improper fraction? I want you to visualize it first. What do you see when you see 1 and 7/10? Maybe picture a circle. Okay, go ahead and decompose it, and then push play to check your answer. Well, my first thing is, how many pieces do I need to make a whole? My denominator is 10. That means I need 10 pieces out of 10 to make 1 whole. So first I'm going to decompose my 1 whole into 10 tenths. Now I still have 7/10 that I haven't used, but it's not enough to group together to make a whole. So I have my 10/10 plus my 7/10 for a total of 17/10, which is the same as 1 1/10. Okay, so if we review, when we want to find a mixed number and change it into an improper fraction, we could think about breaking this one into 5/5, or there is a shortcut. I could take, because I need 5/5 to equal 1, I'm going to multiply 5/5 times 1 is going to give me 5, plus those extra 4 pieces for the 4/5, 6, 7, 8, 9, which would give me 9/5. Over here, I know that I need 3 every time I have a whole. Well, I have 2 wholes, so that means I'm going to need 3 6. I'm going to multiply 2 groups of 3, which would be 6, to make the 2 whole, plus the 1 extra from the 1/3. So I would have 7/3. So that could be another way, a shortcut way. You're doing the same thing. You're just shortcutting it into thinking, hey, I can just say I know I need 3 to make a whole, and I've got 2, so I'm going to multiply 2 times 3, instead of doing the repeated addition where we talk about 3 plus 3 plus another 3/3 to get 6/3 plus the 1/3. Okay? Again, if we want to go the opposite way, and now we have improper fractions, and we want to rename them as a mixed number, which I think is a lot easier to visualize in my head, I could take the numerator and divide it by the denominator. I could say, how many times does the 4 go into 9? So I could count 4, 8, 12 would be too much, so it only goes in 2 whole times. And then I have 1 left over, but I don't just have 1, I have 1 1/4 piece left over. So I would have 2 1/4. Okay? So again, I could use this when I know thirds are going to give me a whole. So I'm going to count by 3s to see how many I get. 3, 6, that's 2 wholes. 6/3 would be 2 wholes. And then I have 2 more left. 2, and I still have thirds. They're still thirds. I didn't change my denominator in both of these. The denominator stays the same, 2 2/3. So those are 2 different ways you can either picture taking them out one at a time, one whole at a time, or you could count by the denominator. How many times can you fit it in? And then how many extra pieces do you have? So how many times you can fit it in whole times is going to be your whole number. And then whatever extra you have left is going to be the improper fraction that goes with your whole number. So now I want you to go back and think about, we've had 2 days we've talked about talking about mixed numbers and improper fractions. Remember, there are 2 ways to say the exact same value. They're like synonyms for the same number. So how do you think you are at being able to convert between a mixed number and an improper fraction? If I started with a mixed number and told you to give me the improper fraction, and if I gave you the improper fraction first and then told you to do the mixed number, would you hopefully be at a 3, 4, or 5? Okay, if you're not at a 4 or 5, then definitely make sure you ask your teacher questions, or if you need to rewatch part of the video again, that might be a good idea as well.